thanks for the warm welcome, and also welcome to this very interesting conference. I'm proud to be part of the opening panel, and I want to explain you the holistic technical risk management, what we are doing during the design stage. As Professor Linke already introduced in his previous speech, the design stage is the initial phase of the facility, which plays therefore an important role. And I want to give you more inside view what is necessary at that stage. But first, before I would like to start, I would give you a brief indication where I'm coming from, and would give you 2 slides only for ILF at a glance. ILF is in the business, in the pipeline industry since more than 50 years. We celebrated our anniversary last year, and we successfully executed, in this respect, more than 6,000 projects worldwide. We are acting in more than 150 countries, and we have more than 2,000 employees. And yeah, it's a family-owned company by 100%. Our services are related to consulting services in the early stage of projects for feasibility studies, bankable feasibility studies, conceptual designs, but we are also doing the engineering, basic design, FEED, front-end engineering design, detail design, and also providing engineering support during the construction activities and the commissioning and startup. In that respect, of course, as these are major projects, we also provide project management services to execute these projects, and for specific topics, we also have additional services, even if it is a seal review exercise or HACCP exercises, where we also can provide our support. Coming back to the topic, the safety first, and why we are performing this holistic risk management. I want to give you some answers on these ones, and also what is the best approach. Is there the best approach? When shall we start with this risk management? And how deep shall we do these assessments? When is the risk safe enough? And are all risks equal or independent from each other? And at the end, how to deal with these risks? And also lessons learned, what can go wrong? These will be the topics of the presentation, and we will dive in now more deeply. Yeah, why do we perform the holistic risk management? Of course, we have to learn from the incidents, and I just made a list of incidents after the last decades, which I derived from a book from the publisher Wiley, Incidents which defines process safety. And if you see, there are very famous incidents on that list, where we have, unfortunately, a high number of fatalities as well as injuries. And this shall give us, of course, the guidance that we shall do it better. And if we are looking even on the timeline, the numbers are getting lower and lower. And of course, this should be our target, that we shall get less injuries or even no fatalities at all. How this can be approached, and what is the best approach? There's a risk management process defined in the ISO 31000, and this is in several steps. First of all, we have to identify the hazard, what can cause a harm or a loss. We have to evaluate the hazard, how serious can it be? And then we have to evaluate the risk, how likely it could happen, is further risk reduction required, and we have to implement then measures if required. The whole process has to be documented and of course communicated, and also lessons learned have to be incorporated, and then we have to review the findings and have to evaluate if it is still valid on a regular basis. And then the process, of course, starts again. Yeah, when shall we start, or what would be the best start? If we are just looking on the upper sketch, which I provided on this slide, you see the safety impact, the red line at the beginning of the project phase. We can still change a lot. We can change the materials, or we can adapt the processes, and this can be done with really less costs or efforts. This can be done during the select phase, and therefore this would be the proper moment in time to start with the risk management. Of course, there will be later on processes where we have then further details, and we can review the PNIDs, we can perform HACCPs, we can do various studies, which I will come later on in detail, and at the end, the possibility to change the safety impact, it's going already in the right direction, and it is very low. Here we have a high impact, and we can do quite a lot, and at the end it will be more and more difficult to add on safety. In the opposite, if you're looking on the cost and then the efforts, of course, any changes which you are doing at the late project phase will be of tremendous costs and efforts. Therefore, it is wise to start with the risk management already in the early phase, where the costs are reasonable or low for the additional safety measures. In that respect, if we look at on a flow chart on the project phases, an initial phaser or project health, safety, security, and environment review should be done at the end of the select phase. And this shall be repeated at the end of the define phase, because here we are still in this area where we can have a significant impact on the safety with low costs. Nevertheless, of course, we have to do also the necessary studies in the detail, safety studies in the detail engineering and procurement phase, during the execute phase, and also during construction and installation. The equipment has to be installed in a proper manner up to the commissioning. Therefore, yes, project health and safety and security environmental review will be an integrated part during the design phase of the project. Yeah, how deep shall the assessment go? In the first step, we have to define the risk assessment methodologies, and there are quite a long list of available, already well-known and established methods, what can be done, starting with the hazard identification, the hazards, and also going further down. Everybody heard already from HACCPs, safety integrity level assessments, and so on. Not all of these have to be performed in each and every project. This has to be defined which methodologies are applicable for your project, and therefore they are partially also overlapping. Therefore, to identify the proper and the required methods, it's the first step which you have to do in your project. And for sure, the most famous ones like HACCP, HACCP, they are all there, but there might be also others which are then more from the maintainability of interest. That means the RAM study, the reliability, availability, and maintainability studies, which will bring you also further parts which are required for the safety aspects. Yeah, second step, define the tolerability and the acceptability criteria. That means what is the risk appetite, let's say, from the company or the project, but also what is acceptable by the legal requirements, and also important on these projects where we are dealing with, of course, what are the lender requirements who will provide the financing for your project. Therefore, even if the risk appetite might be a little bit higher for the company, but the lender is not in favor of that one, we have to follow the lender requirements. And there's a a range where you can see what would be the possibility that a risk frequency that the risk will occur, and there will be levels like improbable, unlikely, seldom, probable, frequent, and of course the risk which happen, it has also some consequence levels which is low up to very high. In that point, everybody will try to get it in the green area and to have it in an inside of the acceptable region. But there's also the tendency, if you have a higher risk and a higher consequence level, where you have intolerable regions, the red area, where you try to shift it as a minimum to the yellow region to get the risk as low as reasonable possible, or if possible, of course, to shift the risk even to the green area. But this is giving you the frequency in cases of years, how frequently this risk could occur. Is it once in 100 years? Is it once in 1,000 years? Is it once in 10,000 years that this risk can occur? Yeah, legal requirements, we already learned also from the previous presentations. Of course, there are also norms and standards which are used by the legal requirements, and these standards, therefore, are also followed in this calibration of the definition of the tolerability and acceptability criteria. Yeah, as a next step, of course, the various studies will be done, like the HACCPs, the HACCPs, the quantitative risk assessments, the safety integrity levels, and this will then have to be properly transformed into a risk register. That means that nothing is missed what has been identified in these various studies, and that it is not just ticking the box, yes, we did the HACCP, yes, we did the seal review, but this has to be implemented and the recommendations or the results out of these. And therefore, the HACCPs, they will first identify potential safeguards, enabling conditions, and to modify and to prevent the risk, but at the same, the top event could still happen. Then there should be also mitigations in place that the consequences are as low as possible. And not to miss any of these identified risks, a risk register is an integral part of the risk management system. Yeah, and in the next step, in the step 4, it has to be defined the risk reduction methods, and that these measures, and it has to be ensured that these have been implemented. That means, of course, we are all try to have an inherent safe design, to have resilience, and to have also emergency preparedness. On the other side, there's the vulnerability, the sphere of influence, and the attractiveness of targets. And all this have to be coming together, that we have to mitigate these and the measures which have been identified to bring the identified risk down with the eliminations, to reduce the risk, and then also to share with all involved parties that risk, that it is on an acceptable level. To document these measures, of course, it is also necessary to have a kind of closeout or HACCP closeout. This has to be properly documented. What was the risk? What mitigations have been identified? How has it been implemented? And at the end, it has to be also signed off by the individual persons who did the implementation of the mitigations. What are typical pitfalls, or what can go wrong? Of course, just carrying out a risk assessment to attempt to justify a decision which has been already done in the past, this does not really make sense. Also using the reverse as low as reasonable possible arguments, like using cost-benefit analysis to attempt to argue that it is now unacceptable to reduce the existing safety standards, it's also not acceptable at all. Also, ignoring what has been identified in the various safety assessments, not doing anything with the results of the assessment is also not the right approach. And also the failure of fully consider all possible outcomes. How this could be overcome, that we involve a team of people in the assessment of the various safety studies. That means that they should have the necessary know-how, practical knowledge, operation experience, also the process experience that they can distribute in these safety assessments. Just doing it as a desktop study by one person is not enough. Therefore, the various experts are required to fulfill these safety exercises. I was also asked to go now further in the next step, what can be considered also during the construction period, and I wanted to give you also some further slides in that respect. Of course, the safety during the construction site is a completely different animal. Just working in the office is something different as if you're working on site with heavy machineries. And there are several companies, every construction company has its golden rules or its life-saving rules. This is taken from CCC, who is also a well-known construction company, and we are currently doing a project together with them for Qatar Petroleum on a pipeline project. And these are pretty standards. Of course, you have to use your personal protective equipment and you have to use them correctly. Of course, if you have confined space entry, you need a training. No training, no entry. There are a lot of these aspects which are important to consider on the construction site to have a safe operation mode in the field. And they are well known and also already good standard. However, it is always important to remind the colleagues to do so and to have the proper training. Just having it on a slide is not enough. This is the challenge every day you are out in the field. And this also includes toolbox meetings for critical construction activities prior and proper training prior you execute the activities in the field. Yeah, if we are looking on the statistics and looking on the golden rules, they achieved quite a lot, and we are already on a very high standard. However, CCC in its own in-house statistics identified fatalities and also lost time injuries when they reversing incidents. That means if you're looking on the timeline, they had 2 fatalities in 2009 and 2010, and also in 2014 and 15. And when they analyzed these fatalities, where were they coming from? That means they had the fatalities by heavy vehicles, and that means more than 2/3 happened when they were moving heavy vehicles in the reverse direction. That means going backwards. And also if they are looking on the lost time injuries, this is also about nearly 20% happened when heavy vehicles were going backwards. In that instance, they analyzed and looked what was possible and utilized a review radar system like it is shown on the next slide. It's maybe even nowadays you find it on your cars sometimes that you have a rear camera, but this is more intelligent. It's also having the radar sensors, and it will identify blind zones behind the heavy vehicles, and therefore, depending if there are people behind the the vehicle and it's going backwards, it will warn the driver of this heavy vehicle that he has to stop. And looking on the statistics, if I'm going backwards, this happened 2015. Since then, when they have introduced it, currently 16, 17, it's not enough time already, but they had no incidents in that respect based on this technology they used. There are other possibilities also and innovations during construction using drones, or as it is correctly named, unmanned aerial vehicles. They can give a greater capacity to forecast problems before they will happen in the field. And they can also be used for large work size more efficiently through aerial photographs and than any on-the-ground personnel can do. In that respect, this will be still it's in the early stage, but it's becoming more and more popular to use these also on construction fields, not only for monitoring and identifying potential safety threats, but also to do survey works in that respect, and also to think about that these can be also utilized for progress measurement. Therefore, there are several aspects which can be covered utilizing drones, and this we will see more and more on construction site. Of course, it has less exposure to difficult places on site, on facilities, refineries, and also earthworks. It can do faster the job. However, it has also safety concerns, and I do not want to hide these. Of course, it shall not be used flying the drones over the top of people, and it should have also the safety landing facility in case of emergency. This is not only limited nowadays to construction activities, we also see it for planning, especially if we are doing site surveys prior. We do the design for pipeline corridors. This can be also used in difficult mountainous areas where you normally cannot go physically directly. That means you could also minimize your own, or from our staff, from our people, the risk utilizing the drones in that aspect to collect and do the data gathering for design activities. Okay, this brings me to an end. I have to say thank you for your attention, and I'm looking forward for your questions later on during the panel discussion.